Okay, in this video, I'm going to introduce the basics of how to do plotting in MatplotLib. So the first thing that we need to do is an import statement. Import matplotlib.pyplot. This is a sub-library of matplotlib as PLT. And of course, I do that so I don't have to write that. I can just write PLT instead of having to write matplotlib.pyplot. So all right, I have this. Okay, so one of the ways to think about how this works is Matplotlib has figures, and within the figure it has axes, A-X-E-S, like the plural of axis. Okay, so it has figures, and within the figures it has axes, and on each axes you can plot something different. Okay, so we're only going to be doing two-dimensional XY things. So for example, we could have a figure that has 4 different XY grids on it. In this video, we're just going to look at a figure that has just one XY grid on it, and then show you in upcoming videos. Maybe I'll also mention in this video how you can get figures with more than just one one axis on it. So to begin with, the best way, so I'm just going to write this line of code and then talk about it. Fig ax equals plt.subplots. What's going to happen here? This is going to return one figure. So this is a function call. What does it return? It returns a figure, and it's going to store it in the variable called fig. It's going to return an axis and store it in the variable called ax. I know it sounds weird when I say it returns an axis because we think about axes as being plural, but within this framework, it really means something singular. You can think about it as being one XY grid. Okay, now if I want to plot something, so the way Matplotlib works, if you want to plot something, it takes in a vector of x values, it takes in a vector of y values, and it plots, so you get ordered pairs. So let's say you have a vector of 5x values, a vector of 5y values. That gives you 5 ordered pairs. It kind of will graph those 5 points and then connect those points with lines. So for example, if I do something like ax.plot, I'm going to give it an x vector and a y vector. If I give it something like 0, 1, 2, 3, and 0, 1, 2, 3. When I plot this is going to give me a 45-degree angle line because this is like y equals x. So you get something like this. On the other hand, if I want to do something like y equals 2x, I could do this. And you get something like this. And you get something like this. Looks roughly the same, just with different scales here. But you can also do, if you wanted a jagged line, let me just kind of put random things here. You'll get something like this. And again, this point would be 0, 0. This point is 1, 3. This point is 2, 2. And this point is 3, 11. And so it just plots that point, that point, that point, and that point, and then connects them together with lines. So kind of at root, any plot that we're going to be making here is going to be technically a piecewise linear plot here. If you zoomed in really closely, you would just see a bunch of straight lines. Now we know that if a function is differentiable, any function can be approximated by its tangent line. So this type of thing is a very natural thing to do. But if you want something to look more curvy than jaggedy, you have to give a finer sort of mesh here, and we'll get into that in upcoming videos. Okay, but now what happens if you want to return maybe a figure that has 4 subplots or something along those lines? So let me just talk a little bit about how we can do that. So here's 3 lines of code. Figure equals plt dot figure. This just returns an empty figure. This returns an empty figure with no axes in it at all. If I do what I did above, fig, ax equals plt.subplots, this is going to return that's what we just did. It was going to return a figure with 1 axis in it. So if I just run that, you'll get this. So this is what you get if you run the second line of code, which is exactly what we did up there. Or if you just do fig equals plt dot, you just get this. Looks pretty similar. Or let's say you want an array of axes, so you could do fig AXS. Now I like to do it's standard to do AXS in this situation. So plt dot subplots 3, 2. This is going to return a figure with a 3x2 grid of axes on it. And so since AXS now contains more than just one axis, we kind of pluralize it there. And when you run this, this is what you get. So you get a 3x2 grid of axes. Okay, now let's say you want to, for example, plot y equals x on this upper left-hand thing here. The way you access that is, so AXS is now a kind of you think about it as being a vector or a matrix of these axes. Okay, so this right here corresponds to 0, 0. This corresponds to 0, 1. This corresponds to 1, 0. This is 1, 1. This is 2, 0. This is 2, 2. So if on this picture right here, I want to plot just a y equals x line, I would do 0, 0 dot plt. So when I do AXS 0, 0, it's referring to the axes or the grid that is in the 0th row and the 0th column. And now I can just do, let's say 1, 2, 3, 1, 2, 3, and you get something like this. I forgot the O. Okay, and so in this place right here, you get a y equals x line. Now let's say right here I want something different. So this is going to be the first row. So this is the 0th row, this is the first row. So it's going to be the first row and the first column, because again, this is the 0th column, this is the first column. So this right here is the first row, first column. So AXS 1, 1 dot plot. I'll just do 0, 1, 2, 3, and then something like this. Okay, and so that's going to be the picture there. And then finally, let's say I want to do something in this picture, in this grid right here. Okay, that is the 0th row and first column. So, and I'm going to do 0, 1, and then 1, 0. And when you run it, this is what you get. Okay, so this is a very brief overview of how to do some very basic plotting using Matplotlib. In the next video, we're going to look at NumPy, which makes a lot of this stuff with the vectors way easier, a little more convenient. And then in upcoming videos, we'll see how we can actually graph functions like y equals x squared and sine x and that sort of thing. It's really great. I think that you'll like it. If you're used to other type of programming like C or Java or kind of stricter languages, it's going to feel unnatural, at least it does to me. But you know, we'll see. That might make more sense when we get to it.